Okay, so again, keep this in mind. This is what we're covering. We just want to understand those characteristics, and then we're going to do those operations. Like, it's not really hard. It'll be pretty easy. I will try to say maybe record a video so y'all could have like, of like say doing the work on the calculator so you'll remember how to store. But again, it's one of those kind of start remembering, because once you start being shown it once, it shouldn't take you that much. And last period they were, how do I do this again? How do I do this again? How do I do this again? I was getting a little peeved. All right. Okay, so we have some definitions. We have some definitions here with a matrix. A matrix is a rectangular array, A-R-R-Y, A-Y, sorry, of numbers in brackets. That's basically all it is. You see a bunch of numbers in rows and columns and brackets. That's a matrix. The dimensions of a matrix are m rows by n columns. Always have the rows first, columns second. The entries are the values, each value in a matrix. M rows by n columns. Each value in a matrix. Sorry. In a matrix. The address is the location of a value given by a lowercase letter, and then you'll usually put a subscript, row, and column numbers. And that's what I'm trying to show there, like with a parentheses, m, little mn. You'll see that more later, but basically an address is the location. Where is that value located? Within the matrix. And then the scalar is a number that's on the outside of the matrix that will multiply everything inside the matrix. Kind of like distributed property, but now in the matrix idea. This example right here, C is equal to 4,800, 7,200, 5,000, 75 10,000, 75 10,000 again, and then 1,125 hundred thousands? Hundreds, thousands. I think it's 1,125 hundred thousands. Okay, with that, looking at that example right there. First question I would ask is, what are the dimensions of that matrix? How many rows, how many columns does that matrix have?
3 by 2.
Okay, it's a 3 by 2. 3 rows, 2 columns. Pretty easy. No, 0, 1, 1, 2, 5. Okay, so it has 3 rows, 2 columns. Not hard, fairly simple, kind of easy. What's the value or the entry at C12? At row 1, column 2, what's the entry? Yeah, the value or the entry. At C, row 1, column 2, 1, 2, what's the entry? What's the value? 0.72. Sorry for those saying it but couldn't hear it. Say it louder. Okay, and finally, what's the address of 0.01125? And this is where, again, you start off with a lowercase c, row 3, column 2, 3, 2. So again, don't forget the lowercase c, 3, 2. You can't just tell me 3, 2, I'll count it wrong. You have to give me that lowercase letter of the, say, matrix title, if you want to call it that, and then give me in subscript the row and column. Yes. C32.
Well, what is it? Is that a 2?
Okay, so here's another example. You've got M is equal to 212151150400912. And again, what are the dimensions? Okay, Do not get it confused with a 4 by 3. That would be different, and I would count it wrong if you switched them wrong test. It's not one of those you get like partial credit for. You get it right or get it wrong. And more than likely, this will not be a grade cam one either. It's too easy for grade cam. All right. What's the value at M32? At 11. And yes, I realize I misspelled this, but oh well. The address, this is with a value of 5. Yeah, nobody second period corrected me when I wrote this originally. Somebody should have. Okay, so how should we rewrite that though?
C.
No, now it's M.
M.
M22 and?
And M.
1, 3. There you go. Okay, lowercase M13, M22. Adding subtraction is pretty easy. There's one very important rule to remember though. And the important rule is that if you want to add or subtract, you have to have the same dimensions. So when we want to add or subtract, the matrices have to have the same dimensions. If I have a 2 by 3 matrix, I need to add it to another 2 by 3. I can add it to a 3 by 2. So you always got to make sure they have the same dimensions. Okay, on page 247, you're going to find, like, say, 4 examples, or 4 matrices, A, B, C, and D. And you're welcome. And I could quickly say, looking at those, like, okay, if they tell me, the question says A plus C. Well, then I should know that A is 4, -3, 2, -2, 10, 6. And I'm adding to it 3, 0, -5, 2, -9, and 14. In addition, all you're doing is adding like the like positions. So what's 4 plus 3? 7. What's -3 plus 0? -3. 2 plus a -5? -3. -2 plus 2? 0. 10 plus -9? 1. And 6 plus 14? 20? Yep, there you go. So look at B and C. Do B and C have the same dimensions? Yeah. Looking on page 247, that's in the book that you don't have open right now. B has dimensions of a 2 by 3. C has the dimensions of a 3 by 2. So, since they don't have the same dimensions, I can't add them together. That means no solution. Automatic.
Wait, could you repeat that? I didn't.
So we want to do this scalar multiplication, which, like I said, is distributive property for matrices. It's just taking the number that's on the outside, multiplying it to everything inside the matrix. So, for example, take the matrix, I don't know, 2, 0, 5, 3, and take the scalar 2 that's on the outside. That number that's on the outside is called the scalar. That 2 will multiply everything in that matrix. What's 2 times 2? 4. What's 2 times 5? What's 2 times 0? What's 2 times 3? Okay, so your matrix should be 4, 10, 0, 6. That's it. Somebody did bring it up, and I'll go ahead and discuss it on here. Somebody brought up, like, what happens if, like, is it possible to have variables? It could be, but like in this sense, and I think I have it on here. Say take 3, 5, x, y, z, and actually, maybe I can go a little further. And then let's say equals 15, 9, 27, and 12. Okay, right there I'm saying, okay, well, what's x? 3, because 3 times 3 is 9. Okay, y would then be 9, and z would be 4. Okay, y'all got that. That's like, that's it. Yeah, sure. Why not? They're not hard when you think about it. All it is simple dividing. Because the 3 times the x gave me the answer of 9. So what's 9 divided by 3? What's 27 divided by 3? What's 12 divided by 3? And then you got your answers. So I can't make it like, it's not like I can make it where, oh, you would have to say subtract and divide or something like that. It's just a straight, it would be a straight divide. Example, talking about this, if I gave you, say, a matrix 7, 3, 2, 4 plus another matrix and said the answer was 7, 3, 2, 4, could you say, tell me what would the answer be? Or what would be the numbers in the middle matrix? 7 plus 1 is 7?
Oh, no.
0, 0, 0, 0. Okay, the additive identity, that would be the additive identity. 0, 0, 0, 0. That is different than tomorrow when we'll see the multiplicative identity. The multiplicative identity is not all ones. But this one, for the additive identity, it's all zeros. So kind of keep that in mind, because I have asked that on a test. Said, what is the additive identity of a 2 by 2 matrix? And I got something completely different. Not 0, 0, 0, 0. Should be kind of obvious. Any questions on that? Okie dokie, your assignment then is Practice B. The Practice B workbook, all of them. It's on page 25. Got plenty of time. I would get started on it now.